Hello. Okay. Hello, everyone. I think now you can hear me actually. Let's see. I'm gonna play some music in the background, just quietly. Um, there we go. Let me know if you can hear me. Very good up that front. If so, make sure to check in. The check-in link has been dropped into chat. And yeah. Today should be pretty fun. It's gonna be one of more the lecture and interactive style of streams where we do. But essentially, we're gonna go over and learn a lot about what is the difference between AI, machine learning, and deep learning. I really break those down, and then we'll really break down machine learning because it's actually the most common form of the use of AI. But yeah, let's get going. Cool. Let me see. Okay, cool. So real quick, my name is Kev. I'm a coach with Major League Hacking, and I use the he, him, his pronouns. I do a lot of different things, so honestly, feel free to ask about anything. And throughout this time, if you want to take a pause and ask about anything, please feel free to do so. But yeah. That's weird. I'm trying to see if there's one you can actually see more. I guess there isn't, so we're going to stick with this one. But yeah. So the schedule overview is really what is AI, then what's the difference between AI, ML, and DL. And then we're going to go through and break down each of the ones we talk about, as well as learn a lot more about machine learning. Feel free to stop me if you have any question. I have also built in question time as we move along. But yeah. And let me know if you can't hear me or if there's any issues regarding those front. So first, a really quick overview and a really quick reminder on what is AI. AI at its simplest form stands for artificial intelligence, which is a field which combines computer science and robust data sets to enable problem solving through predictions and decisions. This is one of my favorite definitions of AI. It is actually written by IBM, which actually has a lot of good articles on generally many things computer science related, from AI machine learning to anything you can think of, like neural networks and so on and so forth. They have really good introductory articles written for every one of those topics. But that being said, let's move on. So today, again, what I've said is we're really going to break down the difference between AI, machine learning, and deep learning. So AI stands for artificial intelligence, which is a technique that enables machines to mimic human behavior. And a subset of AI, which most people would use the term AI, machine learning, and deep learning without realizing that they are really just subsets of each other. So a subset of of AI, which is called machine learning, which uses a statistical method to enable machines to improve with experience. So artificial intelligence enables a machine to mimic human behavior. Machine learning allows it to actually continue to learn the human behavior and actually improve upon through experience after experience. And we go into one nest even further, which is called deep learning. And what deep learning becomes is a subset of machine learning, which makes computation of multiple layers of neural network feasible. But I see we have a lot of new people joining us. So if you are just joining us, make sure you can hear me. And also the check-in link, I will drop one more time. Make sure to check in. So far, we have just gone over what AI is. as well as the difference between the different fields within AI. I mean, the different subsets of AI. In today's whole agenda is we're going to break down a lot of things, and there's going to be a lot of don't be afraid to ask questions, because this is really going to be more similar to a lecture style workshop, as well as where any question is welcome. So we went over artificial intelligence, machine learning, and deep learning. Our next topic is going to be, what is machine learning, right? So we kind of have a better understanding, but a really good definition of machine learning is machine learning is a branch of artificial intelligence and computer science which focuses on the use of data and algorithms to imitate the ways the human learn and gradually improve its accuracy, right? So we're gonna take time later to dive into the different types and forms of machine learning to get a really deeper understanding of how machine learning works. Okay, so before we do that, we also just mentioned and talked about deep learning. So we're going to go over real quick what deep learning is. So a deep learning is known as a neural network with generally 3 or more layers. These neural networks attempt to simulate the behavior of the human brain, which means it allows the machine the ability to learn from large amounts of data without no drawbacks. So the huge difference is that machine learning, the machine is able to learn overall through experience of like essentially trial and error, or there's different, we're going to go over like supervised, unsupervised, and actually reinforcement learning. Deep learning takes it one step further. It's a subset of machine learning that allows multiple layers of computation to occur at once, and that together helps it learn from a large amount of data. So how does machine learning and deep learning differ? Because they really sound really similar right now, right? So machine learning actually leverages structural labeled data to make predictions, meaning that the specific data, before it's trained, it needs additional input that kind of allows it to learn how the data should be modeled and organized. Well, in deep learning allows it to actually take in unstructured data as much as possible. For example, I can just give it a bunch of text and it will automatically be able to look at the text, try to extract certain distinction points, and removing the need for human experts to actually input data. So machine learning requires me to maybe, for example, say, this is a watch. Oops, I just dropped it. But this is a watch. This is a phone, right? In machine learning, I would have to tell it, if you see a picture of this that looks like this is a watch. If you see a picture that looks like this is a phone. But for deep learning, I shall be able to give it the computer just a lot of picture, and itself, as in deep learning, will pick out features that will identify each of these devices, and automatically do that for you. So the key distinction between machine learning and deep learning is because deep learning has multiple layers, and it's a lot more, has a whole network essentially of it's a neural network of multiple layers that will allow it to automatically process that data and look for exact points to distinguish them, and then does classification. I'm going to take a break here. Is there any questions so far, especially if you are joining us right now on anything I've gone over? If not, that's perfectly okay. Let's going to go back over this chart again. So as you can see, what we've talked about is that artificial intelligence is the broadest field, with machine learning nested inside. Artificial intelligence, it just allows machines to mimic human behavior, while machine learning allows machines to learn through experience and with some provided framework. Oops. Followed by deep learning, but of machine learning that actually allows multiple layers of neural networks to work together and take away the issue with when machine learning. A human has to give it data, or have to provide a base of learning and deep learning that gets abstracted out, and the machine itself, through its ability to take in so much more extra data, it can actually learn a lot of that on its own. But yeah, so let's see. So out of a lot of AI you actually see out there, a good chunk of it actually becomes machine learning, where you train an AI to do a specific task really well. So a lot of your chat bots, a lot of your other known devices, known AI usages are generally mostly machine learning. For example, maybe your smart home speakers, they've been trained to do a specific thing. So they've been trained on data. For example, have you heard of resume reviewers? Those are also trained on specific data. So they all fall under the category of machine learning. You rarely see deep learning because that requires a lot more technicalities, especially with building multiple layers of neural networks. So we learned so much about machine learning, and we just learned that it is the primary form of AI we generally see, where we're able to train an AI model. So how does that really differ from traditional programming? The difference is pretty clear in this article, right? So in traditional programming, what you do is you write the program, and then you give it the program data, and together when the program takes the data, it generates something called output, right? For example, if I wrote a program that will parse through a CSV and graph it, I will give it the data to CSV. So I will take the program, take the CSV, and output will be example a graph. And here's how programming traditionally works. How machine learning works, though, is it really differs from that. Machine learning actually takes the output, right? So you first feed it an example of what the answers will look like. So you give it a sample answer key, essentially. Then you give it data, and together with the answer key of possible outputs in the data, it will try to learn by going, okay, so the answer key says things that look like a square things that look like a rectangle with two buttons on the side is a phone. It will look at the data to see how much the data actually matches, right? So it will actually use the sample answer key to try to infer how much the data actually match, and that actually will not be it for machine learning. Machine learning then will take extra data that's not corrected, right? So first we have output, so we know what the data actually is, right? So it's data that's been known. Then we take output of, we know what each of the data actually will fall under in terms of categorizing, right? And then you also feed additional data it doesn't know, and then that computes the output. And what we actually get out of the end of the day is a program that can classify, right? So if we give example, if my output is to classify flowers, right? So the data would be a bunch of flowers. The output would be the correct categories where each of the data flower goes into. That gets fed into the computer. Then you take data that you don't know anything about. That means you don't know the output about. That gets fed into the computer. And then you produce an output that is statistically driven on what's correct and what's not. And then from there, what you get at the end of the day from that is you get a program that is able to take raw data and compute output. I'm not necessarily sure what this question is about because we actually won't be deploying any of our models. We're really just going to break down the different types of machine learning. This is more of a theoretical class to make sure you understand, workshops to make sure you understand machine learning as you are going through the different type of other workshop where you might apply some of these concepts. So yeah, I'm not super sure what this question is asking, but do we have to deploy our models on the web, or we can just show the Jupyter Notebook? Is this question directed towards something specifically? Oh. Okay. This is actually super interesting. You're talking about actual event. I'm assuming that's happening this weekend at Galactics. This stream is for Global Hacks Week, where we actually go over a lot of basic workshops. So for example, this one is on what is the difference between AI, machine learning, and deep learning. If you're wanting information about HackLastics 2023, which I know is a hackathon that MLH supports, you probably want to actually reach out to the organizers who are on site and the MLH people who might be staffing. I highly doubt there's probably any MLH table at the table unless you're in a different time zone, which I don't know. But that being said, from my past experience, because I do go to hackathon events and stuff, as a MLH coach, do we have to deploy a model on the web? Which, as long as you can demo it and then explain your project, you'll be good to go. But yeah, this is completely separate from any hackathon you're at. This is our MLH's Major League Hacking's Global Hack Week, where every week of a month we take a topic and we really break it down. But answer to your question, just showing the Jupyter Notebook is probably perfectly fine, as long as you fit that fits under a category and you can demo it. You don't have to deploy it. But there might be other things that are activate or other categories you might want to deploy to get more points. Hopefully that answers your question. You should be able to, again, I would check with the organizer at the event you are at. But that, from my past experience as a coach on events, that should be perfectly fine. But again, double check with the organizer if you are at the event you're at. Yeah, for sure. Okay, cool. So moving on, we're actually gonna, we just learned the difference between machine learning and traditional programming, and we figured out why machine learning is such more of a powerful tool than traditional programming. Given the fact that at the end of the day, instead of just ending up with output and we have to write the program, all we had to do was tell it what we think is kind of correct, give it some data for it to try to learn from, and then it will actually write the program and logic that will determine if what we want to do, right? So this takes us, we've spent all the work writing the actual program, and then after that, we have to provide the data and get an output. And this is a one-time thing, right? We put all the work here. This, we just have to create a sample output. So I can say like 1 + 1 is 2, 2 + 2 is 4. Give it some sample results are correct. Pass it in, give it some data that's not been correct, that's not been checked. Pass that in as well. It'll generate output that will be considered and checked for statistical correctness. And then at the end of the day, you end up with a program that will allow it to do essentially this without all that work. So machine learning by itself is already pretty complex. It actually gets even more complex. I'm actually gonna make this bigger in case you guys can't see. It gets actually even more complex in the sense that machine learning is broken up into 3 really general categories. So you have something called supervised learning, something called unsupervised learning, something called reinforcement learning. And here are how they are different. So supervised learning generally makes machine learning explicitly. So first, we start with data that are clearly defined with outputs that is given. It provides direct feedback is given, and it is able to predict outcomes and future of some data, right? So how it works is you give it input, it trains on it, and then it produces output. But you have to provide it the training portion, which means you have to provide it the data that clearly defines what is correct and what is incorrect. Then you have unsupervised learning, where the machine really understands the data and tries to distinguish each data apart. So you kind of just provided the input, and it'll automatically give you the output. There's no training needed. The last of them all is reinforcement learning, where you give it an input through a type of reward steps system. You come out with different outputs, and it will slowly learn what is the most optimal. We'll go over each of these more in depth in a second. But before we even do that, let's really look at what each of these machine learning are going to be used for, right? So machine learning, if we talk about supervised learning, you have 2 types. You have something called classification, and you have something called regression. Classification are generally used, and you can think of it as pretty oh, my mind is blanking. It's pretty clear what classification is, right? So it helps you identify things. So classification, or supervised virtual learning classification, it can be used to identify fraud. It can be used for image classification. It can be used for customer retention. It can be used for diagnosis, right? So it gives the machine learning algorithm the ability to classify items. Supervised learning regression, what that does, it allows prediction, right? So it allows you to predict, let's say, popularity. It allows you to do weather forecasting, market forecasting, estimating life expectancy, population growth. So regression allows us to be able to get predictions for different parts of predicting the future, while classification allows us to figure out what type of object each of them is. And we'll actually go into those more in a little bit as well. Then we also have next is unsupervised learning, which you have two types. One is clustering, which allows you to unsupervised version doesn't actually allow you to use it for prediction. What it actually allows you to do is help you better understand the data and look for patterns, right? So unsupervised learning, let's say with clustering, is such that you give it a bunch of items, it will figure out how each of them are connected and start generating clusters. So this is really useful for things such as identifying customer segments, looking into recommendation systems, right? So things that are really closely related will get clustered together. Targeted marketing, because you're able to look at what branches or sub-branches of the market are really similarly closely related. For example, teachers and students are a thing that can get clustered together. Unsupervised learning, like generation AI that learns from previous generation itself. I am trying to think on necessarily what you mean. So again, this is a really open conversation. So when you say unsupervised learning, like generation AI that learns from previous generation of itself, that's a unique one. Actually, does that fall under unsupervised learning? I guess it does, doesn't it? Because you don't have to pass in anything else; it would have already known. That's a pretty cool concept. I'm actually looking into that a bit more later. But unsupervised learning, another branch of it is called dimensionality reduction. That is cool. So I'm gonna save that YouTube video for later. So dimensionality reduction allows it to meaningfully compress things, allows it to do big data visualization. It allows you to do structural discovery, and it's a whole nother subbranch. Actually, I'm not too familiar with dimensionality reduction. I'm really familiar with clustering using unsupervised learning, classification regression with supervised learning, and last but not least is reinforcement learning, which is essentially a reward system. It's kind of like that psychology, I think, study of how you provide a reward, it will provide. I think they use monkeys or something where every time the monkey does something provide a reward, it'll learn what's correct and what's wrong. And we'll go over how that works in a second. But that is a great video. I guess if anyone's interested in learning about how unsupervised learning can be like when a generation of AI learns from a previous generation of already trained AI. But yeah, I think that is pretty cool. I'm gonna leave the YouTube video link up for a bit. Pretty cool if you want to check that out. Is there any question about anything we've gone over so far? I'm gonna take that as a no, and we're gonna take a small pause break here. Chillax, how's everyone's day been? Or I guess some of your days might have just be getting started. Actually, let's take a look. While we take a short break, if we're gonna get some water, I'm gonna look up this YouTube video because that seemed really interesting. YouTube.com/watch ? I wish I could copy from chat, but that is just an ability that they have disabled. It's a feature I can't use. It's unfortunate. Okay, cool. Let's take a look. Wait, are you sure that's a right link to the video? I just popped that in, and either I did type something wrong or that video doesn't exist anymore. Yeah, I know. I think I just double checked. Code Bullet. That sounds so familiar. Code Bullet. Oh, I do know Code Bullet. That's so funny. Code Bullet does a lot of AI stuff. It's actually a really cool channel. Actually, I'm gonna throw this up. This is actually pretty cool to look at. He does a lot of AI stuff. I've seen actually a lot of his video where he trains AI to do stuff. Skip to 137. Do you know what video it's called? I can't remember the regulation about me watching a YouTube video on stream. I don't know if I'm allowed to or not. But I don't which area. Do you know which area video you're talking about? AI learns to run. AI learns to walk. Creature creator. Oh, I see it. See it. Let me see. Let me take a look at those. Yeah. Hold on. Let me skip to minute 37. There's so much ads on YouTube. One minute 37. Yeah, no, I watch this later. It sounds pretty cool. I'm gonna go grab a cup of water real quick. I think there's actually a screen for this. Actually, we're also probably gonna pick a better song. Before we break down into more of the AI stuff, let's try that. And then I think if I'm not wrong, it should be a "Be Right Back" break screen. Or I could just be heavily crazy. Is this it? Oh, coffee break. Whoa, that's a cool. We'll be right back. Let me see. I think there is. There you go. Right back. A short break. Before we continue. Okay, we're back. I just grabbed some. I don't know if you heard of Karma. Um, I mean, not like I'm pretty sure everyone has heard of Karma. Ask me any question if you have anything, but it is a type of like probiotic drink, but it's not. It's actually not bad. It's like this. So like it has probiotic on the top, the cap, and you kind of just push it through, and then it mixes with the water. I really enjoy it. The only issue I would say with it actually is that the cap isn't sealed. It's sealed too well in the sense that if it will like you will spill the drink if you because you know how like the top of your cap, if it's sealed, you have to twist it until you break the seal. The cap at the top is sealed so well that like I generally cut it with a knife because where else when I untwist it, it will accidentally spill the drink because part of the cap will become open while the other part won't become open. I actually don't know. Maybe it's not good, but I just think it's like too good. It just sticks on too well. It doesn't all rotate off at once. So I generally cut it with a knife first. So when I go open it, I'm not actually really breaking that anymore. I am just getting the top off. Okay. Now that aside, let's get going. So real quick, we're gonna go over supervised learning. So we talked about the two different groups within supervised learning. But really quick, what is supervised learning? Supervised learning, again, is when the machine learns by using data, which is labeled. With some of it is labeled, and some of the data is already being tagged with the correct answers. For example, I would already tag a few pictures of cats, so when I give the machine more cats, it has something to actually compare it to and understand what is a cat. Supervised learning, it uses label to train data, and also it allows it to actually help you predict the outcome of data you've never seen from the learnings it's done with data that it has labeled and from the data you come in with already correctly tagged, which applies to two types of problem we actually talked about. Again, it's classification and regression. Classification, as you can see in this chart, it's really just the AI will start to make groups, and let's call it classes to sort each object that comes into, right? So you can see there's a line where all the X's are sorted to one side, all the O's are sorted to the other side. It allows it to be used for predicting and identifying categories or labels of given data points based on the training sets of the data containing observation whose categories membership is known. The output of the classification problem is generally discrete. You can use this, for example, for like image classification, right? Because you can teach it what something looks like and have it classified to parts of the images. You can use it for, let's say, handwriting recognition, right? Because you can show it what XYZ is to tell this is what zeros, all zero looks like, all ones looks like, all twos looks like, all threes, fours, etc. You can use it for spam filtering, right? You can say, here is a spam email. Go take it through a classifier, and the AI will go, does this look like a regular email or does this look like a spam? So spam email with spam filtering is one of the most common common version of classification that you've probably seen and actually interact with. But yeah, so that is classification, and then we have is the next part of supervised learning, which is regression. How this works is it uses the ability to determine relationships among variables, and then using that relationship to predict the outcome of any new event, right? So the outcome of regression problem are generally continuous. For example, as you can see in this chart, we first drew you took all the data, then we drew a line, and this is the prediction line, right? And then for, let's say, a point where there's no data, we can use this, AI would use the amount of data it has to predict where the unknown data would be. So a lot of this usage would be used in such things as like medical diagnosis, or like strategical arbitrage, where you can or weather or temperature forecasting, right? If we know we have a lot of data points of when weather could be, and you can just move that down and right on the actual axis and figure out a prediction of what something would be. This is a lot to do with actually linear regression and different type of modeling, which is what AI is really focused based on. So yeah, it takes this, figure out what type of trend it has, and then you can use this to predict future trends. Again, the next thing we're going to go over is called unsupervised learning. And what is unsupervised learning? Unsupervised learning is you first start with raw data, which the machine will be allowed to discover information on its own. And it mainly generally deals with unlabeled data, and it allows it to sort them out. And this can actually be more complex of a processing task compared to supervised learning, where you kind of already give it some things that are marked correctly. So it actually only has to identify if it is something or not. Through the clustering part of supervised learning. Unsupervised learning, you're just giving it data with no clues, and the machine itself has to figure out how things are related. So right, so over here you can see it gives it raw input data. After it collects the raw input data, the machine will try to interpret it, it'll pass into the algorithm, it'll process it, and then we'll try to sort it into the different types based off of how similar they are. Another good example is generally if I give it all this, right, it can then start clustering the different types of data. So this also, I personally think it's also kind of like another form of clustering, with the major difference being in supervised learning, clustering, you already told it a few of the few of what it actually looks like. Well, I mean classification, right? So clustering is for unsupervised. So in classification, you already told it which ones are correct and how to sort them. So you can go cats go here, dogs go here. In clustering for unsupervised learning, you don't tell anything, and the AI has to by default look at features, identify features, and slowly cluster or put things that are more related next to each other, and you get to form these kind of like nice circles and be able to tell difference from each other. So an example of unsupervised learning would be used for, let's say, identifying automatic segmentation and like tumor extraction for brain MRI images, right? So this doesn't require training because all you gotta do is give it a bunch of data and allow the computer to sort the data into its proper categories. And then once that's been done, all you gotta do is look at the output and you go, okay, so this could be MRI with tumor. This won't. This is, right? Because all you're doing is you're allowing the actual computer to sort everything out for you. After it's sorted, you can go back and actually label it. Clustering is actually a really powerful tool in unsupervised learning because you don't have to give it anything correct or wrong, anything labeled correctly in the beginning, and it will do all the work. And then from there, you can look at the clusters to make inferences and learn more about each section of the data. Okay, so the last thing we are going to talk about is reinforcement learning. So reinforcement learning, again, is where there's a machine, or also known as the agent, which learns by interacting with an environment, right? So how that works is the agent either does something correct in the environment and receives a reward, or the agent does something incorrect in the environment and receives a penalty. So you're essentially, it's a punishment, it's reinforcement, right? So it's a punishment reward system. How that works is the machine is not told how to perform a task or what is the correct way to perform a task. The machine will just be thrown into the environment, which is kind of like a simulation. And it would just continue to operate in the simulation. Every time it does something correct in the simulation, we give it a reward. Every time it does something incorrect in the simulation, you could give it a penalty, or you should give it no reward. So how this works is, right, you take raw data, you input it, the agent will start in this environment, it will then try to choose the best action, and if it happened to choose the best action, it will gain the reward. A state in reinforcement learning is one snapshot of the environment, and this cycle just repeats and reverse, right? The agent in this environment will take an action, the action will then be determined by the environment as a good action or a bad action. If it's good action, the environment will then reward the agent, right? This is how you would train, let's say, AI to play a game, right? So, for example, if you're training AI to play Mario, and in round one, if it writes and move the pixel to continue the game, you would give it a reward. If, let's say, it goes backwards, you'll give it either a penalty or no reward, or set it back to 0. And this will essentially reinforce the AI and help it learn what is the proper thing to do, what's not, because you slowly, every time it does something correct, the score of reward will slowly grow. But yeah, that is the really basics of AI. We're going to do a quick overview of everything we just went over, and then we're going to take some questions, and from there, I hope... Oh, real quick, my bad. I also want to go over some examples of reinforcement learning, right? So a really big one is like the e-commerce platform Alibaba incorporated reinforcement learning, and it's optimized to optimize its real-time bidding for display advertising. What that means is you can see that a lot of places and help build reinforcement learning into it by when something good is happening, you will give AI a positive, and when something bad, so the AI will learn what is the best choice of action in any type of environment or system. Okay, as you have a question, please feel free to drop in chat. We'll go over a quick overview of what we learned so far. I think this is probably the best thing. Actually, let's start from the beginning. So we learned the difference between AI, machine learning, and deep learning, how they're really all subset to each other, with AI being the top, which means essentially it's a technique that enables machines to mimic human behavior. Then we have machine learning, which is a subset of AI, which uses statistical models, statistical methods to enable the machine to learn from experiences, which could be done through reinforcement learning, we've learned about. We can also be done through supervised learning or unsupervised learning. We have learned that deep learning is an even smaller branch of AI, which falls actually under machine learning, where you have multiple layers of neural networks that allow it to take the data and learn from it without providing any type of label, tags, etc. It is a powerful version of machine learning because we're using so much more computation power. We learned the difference between machine learning and programming, where traditional programming, you have to provide the actual program plus the data, and then it will give you the output that you're seeking. Well, in machine learning, all you got to do is make up some sample data and tag a few of them as correct. Then you pass it in so the computer know what it is, what should be correct and what should be incorrect. You pass in more data that has not been identified. You'll get output that you can gauge to see if your machine learning algorithm is doing correct or not. And then there you'll end up with a program that will allow you to do either clustering, classification, or any other type of machine learning structure from there. The different type of machine learning we have learned is supervised learning, unsupervised learning, and reinforcement learning. With unsupervised learning having the most common type, which is clustering, where you give the computer data without telling it how to sort the data, and the computer has to look for common identifiers on each data point to start grouping them together as closely as possible. Then you have supervised learning, which you have two types, which is classification, regression. Classification is when you first give the computer a few examples of what is correct, or what is, let's say, a cat or a dog, and then you let the computer slowly take a dog, compare it to the answers it has to determine if it is a dog or if it's a cat. This is used in a lot of image classifications, identity fraud detections, and so on and so forth. Then you have regression. Regression in supervised learning is the ability to take data points and compute what the results would be from the data points with a thing that doesn't have a data point. I think it's easier to show you here, right? So with all these data points, we'll compute what the result could be at this point on the x-axis without knowing what the y is, because we don't have actual numeric data point there. But we can use what the data point we have to generate a good prediction of what it is, and that is regression. The last but not least version is reinforcement learning, which are generally used a lot of time for real-time decisions, game AI, etc. Now, reinforcement learning works real quick is, again, it takes the agent, and which is the learning person, and then it puts the agent in an environment, which the agent can do action. Each action the agent do that we think is correct or beneficial, we reward the agent. Each action the agent does that we think is non-beneficial, we penalize the agent. And slowly, what this does is it teaches the agent what we want it to do and what we don't want it to do. From there, you end up with a program where the agent who knows how to do something exactly correctly. And this is really clear. And when you look at game AIs, where AI is able to complete a game, all you do is you put into environment, you train the AI saying each time it does something correct, right? Let's say the score goes up. It's actually, game is one of the easiest way to train AIs for, because if a game that has a score, as the score goes up, it's doing something correct. And if it fails, it needs to go back and try to do something better to make it correct. Cool. So any questions about what we've gone over so far? One of the really good ways to reinforce a lot of this, especially with reinforcement learning, is using things such as AI Gym, which they have environment already set up for you, and all you got to do is go in and then learn how to train agent in the environment, and by defining its state and what is good and what's not. I've seen beginners be able to train an agent to play Super Mario correctly, and it is pretty cool and pretty wonderful of a thing. But yeah, any questions about anything we've gone over? or just any questions in general. This is a pretty chill environment generally. We take any questions and I try to answer them the best I can. This is my understanding of AI and machine learning. But yeah, feel free to ask me anything in chat. I'm just gonna hang around here. Actually, I really don't know. I really want to watch a YouTube video kind of live. I just don't know if I'm allowed to. It's on Twitch, right? I feel like I've seen people on Twitch watching just YouTube videos, but I don't know if I'm allowed to do that. You think I will get deleted? Oh, thanks for the warning. I did not know that. I guess I'll watch that on my own time. But yeah, it's pretty sad. I think for this Glow Hack Week, I wanted to do more actual practical things. The issue is AI and machine learning. I'm only ethically and theoretically trained in it. I don't have as much practical experience of applying this stuff, so I end up being put on a lot of lecture-like topics, like understanding what AI actually is, understanding the difference between AI, machine learning, and deep learning, what they are. I would love to actually do something technical. So, deep neural networks. Well, deep learning is actually a sub-branch of neural networks, so that's actually really cool. But yeah, I think later in like 8 hours, I'm being forced to do another workshop, and the next workshop is actually on just playing around with AI. So you get to see all sorts of different AI, and it should be pretty fun. And after that one, I think what we have is I will actually be teaching. This is what actually I'm really looking forward to this one. I'm going to be teaching computer architecture, learning some assembly, what a computer has built into it. I don't think I'm going to go to the actual super architectural level, but a lot more of the assembly level. That one I'm really looking forward to. It's really in the evening and stuff. But yeah, that one, it sounds pretty cool. Yeah, no. I really can't wait to teach computer architecture. That one I'm looking forward to. Actually, I need to wrap up making some of the slides for it. Wait, are you talking? I'm not sure what this acronym means. Are you talking about like entity relationship diagrams is my best guess? Wait, I'm not teaching databases though. At least that's my understanding is that has to do with like database stuff. I'm gonna be doing one on assembly. Well, at least my idea is, I'm thinking is for the computer architecture one, we're gonna go over how different parts of computers, so like register level stuff and assembly stuff. Because at the end of the day, I want to be able to teach one day a workshop on malware analysis, which is one of my favorite domains in cybersecurity. I have a focus in cybersecurity, not AI, but that's a different story. But to do that, I need to run a workshop on assembly and on like computer architecture, so you understand how to read assembleized malware or disassembled malware, actually. But yeah, that's a work in progress. We're still working on. But yeah, so we're gonna attempt to teach computer architecture live. We can actually go. It depends what route we go. We can also teach like things like the actual architecture, like it's like ALU, the computer's clock, etc. I think that's less fun than learning like how the different type of registers work and like how that translates to machine language. I meant to say how that translates to assembly language. But yeah, that is going to be fun. If you guys ever have any ideas on a good workshop or something you want to learn, always feel free to let me know. I'm just gonna do some research, learn it myself, and then teach it. Any topic. Yeah, I consider teaching also gradient descent as a lecture, but I was afraid that it was gonna get too mathy And if you were just trying to teach gradient descent on like a theoretical level, there's not that much content there. So we shied away from gradient descent. Okay. I'm gonna do this actually since there's not that many questions. I'm gonna stick around for a bit longer for any questions. If there is not, we might call it a good night. And I want to thank everyone for showing up and joining me tonight and going over some basics of essentially AI and machine learning. And then I will see anyone again who will be up at 10, 8 hours from now, whatever time zone you're in, 8 hours from now, where we will be going over some stuff. Yep, thank you. Good night. Yeah, what's funny is I really didn't want to do this because essentially I have to wake up in like less than 6 hours and then prep for the next workshop and get back on stream. But yeah, thank you everyone for joining me tonight. Make sure you get some rest as well. I do want to highlight real quick before everyone just dips out of here that we have another workshop happening tonight at in an hour from now. I think I could totally be lying, but let me double check. I should know this from the top of my head, but I don't. So that's a whole different story. Yeah, so after me, we actually should have. Today is definitely February the 10th already. So we have. Wait, why is this so wrong? Oh, I guess it's not wrong because it's done differently. So right now is 1 a.m. EST. Well, it's actually 2 a.m. EST now. We did what is different between AI, ML, and deep learning, or DL. Next, we have 4 a.m. EST, which is in essentially 2 hours from now. We have an inclusive AI stream, and that's sounds like a really fun one. At 6 a.m., we have a learn machine learning with no code with Lobe AI. And then following that, we have creating a chatbot part 3 at 8 a.m. EST. And then with that, in 8 hours from now, I will be back online for 10 a.m. EST exploring the powers of AI, which we will actually go get to play around with some of the different AIs on chat live. Everyone can join me. I'll show you some of the cool AIs I've discovered, and we will get to play with them live. But yeah, I hope everyone do show up and enjoy the rest of Global Hack Week February, AI and machine learning. But for right now, I do wish everyone a good night and come back in 2 hours for the next workshop. Have a good night, everyone. Thanks for coming out here.